Welcome to another video in the Visual COBOL for Eclipse in a Nutshell series. In this video, we'll take a look at the reverse debugging and live recording features of Visual COBOL for Eclipse. These forensic investigation tools for your microfocus COBOL applications include reverse debugging, which allows you to step backwards and forwards through already executed statements in the debugger, and live recording, where you can capture execution of a COBOL application run outside the development environment, for example, in a QA or production environment, for later playback and step-by-step review in the debugger. These features were first added to Visual COBOL 3.0 as a technical preview and were considered GA in version 4. The demonstration in this video uses Visual COBOL for Eclipse 5.0 installed on a Windows platform, connected remotely to Visual COBOL Development Hub 5.0 on Linux, each with the latest patch update installed. For details on setting up remote development, please see another video in this series, Using Eclipse for Remote Development in Visual COBOL. The reverse debugging feature allows you, while debugging a program, to step backwards through previously executed statements. As you do, variable values shown in the debugger change back to their prior values. When running in this mode, the debugger shows additional reverse versions of debugger transport options. So there is a reverse step into, reverse step over, reverse step return, and reverse resume. If you have used the keyboard shortcuts for advancing execution in the debugger, adding the Alt key gives the reversed version. For example, F5 is the shortcut for step into, and Alt F5 is the shortcut for reverse step into. As we'll see shortly, breakpoints set in the debugger also affect reverse execution. Running full speed in reverse, launched with reverse resume, will stop when a breakpoint is encountered, just as with forward execution. The reverse debugging feature is only available on supported Linux operating systems running on x86 platforms. This support includes the ability to remotely debug applications executing on Red Hat and SUSE Linux, even if the Eclipse debugger is actually installed and running on Windows. Finally, only COBOL applications built to native binary formats are supported. So GINTs, shared objects, and native executables are supported, but int files are not. This feature can be very powerful, as it helps avoid what I call Groundhog Day debugging. You have an application problem or failure that only happens intermittently or under certain circumstances. You've carefully assembled the required data files and other setup to try to reproduce the problem, setting breakpoints in the area where you think the problem occurs, and investing lots of time stepping through code and checking variable values. When you see evidence of the error, you discover that you're past the point of identifying the value or path through the code that triggered it. So you reset all of the required data and start the debug session all over again. And again, as many times as it takes. What if instead you could just execute backwards and forwards as much as needed through the code in the first session to isolate the problem? The reverse debugging feature in Visual COBOL for Eclipse is turned off by default. In order to use it, it must be enabled in a debug configuration as shown here. Let's take a look at a simple example of using reverse debugging. At this point, I've started the debugger after enabling the reverse debugging feature as just mentioned. On the debugger toolbar, I see that in addition to the normal buttons to advance execution, there are now buttons for reverse step into, reverse step over, reverse step return, and reverse resume. I've set a breakpoint on the last line of this paragraph, which prompts the user for some information. Now I'll use resume to start the program running at full speed. It prompts the user for a couple of pieces of information and then stops at my breakpoint. In the last two statements prior to the breakpoint, variables have been updated by move statements. I'll add these variables to the expressions view to make it easy to monitor their contents. Using reverse debugging causes execution to be undone as you proceed backwards through the program. When I click the Reverse Step Into button, the effects of the prior statement are reversed. So the target variable for that statement reverts to its prior value. I see that the variable identity location is now back to the value of spaces that it had before this move statement was executed. This way, when I encounter an unexpected value or condition during a debug session, I can walk backwards to see how that condition or value came about. Breakpoints set in a debug session also affect reverse debugging. I'll set another breakpoint at the beginning of this paragraph and then do a reverse resume. The reverse execution proceeds at full speed back to the prior breakpoint. Then I can step forwards through the previously executed statements again with Step Into, and as I do, I see the effects of these statements being reapplied in the variables view. It's like watching a recording from closed-circuit TV. I can only see what's happened while the recording was being created. While I'm debugging this way through statements that have already executed, the debug view shows that I'm in replay mode. I can't change the flow of execution or modify the values and variables as I normally can when debugging normal forward execution. When I reach the point of stepping past the last statement that was originally executed, the debug view changes to reflect that I'm no longer in replay mode. I'm back to live execution of the program. Visual COBOL for Eclipse also supports the live recording feature. This allows you to record execution of your COBOL application in any deployed environment and then step through it later in the debugger. As with reverse debugging, live recording is only supported for applications executing on supported Linux x86 platforms. Recordings can be played back in the Eclipse debugger using an Eclipse debug configuration named COBOL Live Recording. The same reverse transport options are available during a live recording debug session, and variable values shown will change to reflect what they held at the current point of execution. No new user or file input is accepted during the replay of the recording. This all comes from the recording. This feature is enabled by setting an environment variable named COB Live Record before starting execution of the application. This variable is set to specify a prefix that will be added to the recording file that is produced. By default, the file will be produced in the present working directory of the application. Or you can optionally specify a target directory for the recording file as part of this setting. The recording file name includes the prefix, the executed process ID, and has the extension .mfr. Please note that there is some impact on performance of an application when the live recording feature is enabled. If you are using the Micro Focus COBOL application server named Enterprise Server, a utility named COB ESLR is provided to allow you to specify which web service or application instance should be recorded. The use of Enterprise Server is beyond the scope of this video. Now, let's take a look at the live recording feature. For this example, let's assume the same program shown earlier has been deployed to a QA or production system, where a crash has been reported by an end user. With live recording, the end user can be instructed to create a recording of the failure by setting an environment variable COB Live Record. Now the end user reruns the program so that the error occurs. The resulting recording file is provided back to development. In Visual COBOL for Eclipse, I've configured the debugger to use the recording file, using a debug configuration of type COBOL Live Recording. The configuration references the COBOL project that was used to develop the programs being debugged. And I can browse for the live recording file that's been transferred from the system where the failure occurred. When I launch the debugger, I can run full speed until the program fails by clicking the Resume button. The error that was produced when the program terminated is displayed. After clicking OK, I'm positioned to the line of code where the error occurred. I can hover over variables to see the values they contained at this point. I see the reason for the error. The subscript value num1 used in this statement contains a 0, which is an invalid subscript value. But how did a 0 get into that variable? At this point, I could use the reverse debugging buttons to step backwards through the program, seeing the flow of execution that brought me to this point of failure. As with reverse debugging, I can see not only the final variable values at the point of failure, but their prior values during the program's execution as I step backwards. However, a faster way to determine where the bad value came from is to ask the debugger to let me know when the value of this variable changes, and then run execution in reverse. To easily do this, I'll click on the variable to select it, and then right-click and choose Toggle Watch Point. In the breakpoints view of the debugger, I can see that a special breakpoint of type watchpoint has been created for this variable. Now I'll click Reverse Resume, and the program will run back to the point where num1 was assigned the value 0. This is the problem statement that may need to be changed to avoid 0 getting into my subscript field. This completes this video about the reverse debugging and live recording features in Visual COBOL for Eclipse. I hope you find this information useful.